All right. Welcome to this seminar. It's going to be about Git and GitHub, which are technologies that you can use to do what's called version control, keeping track of different versions of your program, testing out new changes, etc. All right. So before we get started, we'll do a quick introduction into kind of what Git and GitHub is all about and what it can be used for. And then we'll go more specifically into kind of the command line commands that you would use in order to use some of this technology and leverage it for projects that you're working on or projects that you're collaborating on with other people. So first of all, what is Git? What can it do? The first and one of the most important features for Git is that it can keep track of changes to your code. So if you have code, you create a file, and maybe you're making changes, Git will keep track of all of the different changes that you've made to your code, such that at any point you can kind of go back and see the history of whatever it is that you've been working on to see what were your earlier changes and when did you make those changes. And that can sometimes help when you're going back and trying to debug and figure out what went wrong at some stage in the code process. So that's one thing that Git can be useful for. Another thing that it can be useful for is synchronizing code between different people. Especially when you're collaborating with other people, Git is valuable for trying to make sure that your code potentially matches the code that someone else is working on. And at any point, absolutely feel free to interrupt me if you have questions. If something doesn't make sense, I'd be happy to field questions as we go. So imagine that you and a collaborator are both trying to work together kind of on the same piece of code at the same time. So maybe that code lives somewhere on some server, and there are a whole bunch of servers that can host what we call Git repositories, just folders that contain files that are tracked via Git. GitHub is one example of that. So maybe both you and your partner need access to the same file. Maybe you both make changes to that same file. And what Git allows you to do is Git makes it very easy to then take those changes that you both have made independently and to kind of merge them back together when you push them back online to the same file, and then pull those back down to your own computers so that you both have the latest changes, not only what you've changed on your file, but also what a potential collaborator has made changes to as well, and you both have the most recent up-to-date version of the code. And so synchronizing code between different people is another really valuable thing that Git can be used for. A third valuable thing that Git can be fantastic for is to test changes to your code without losing the original. It's all too common that before I started using Git, would try making changes to code to try and make it better, and then suddenly find out that the code no longer works. And so my original solution to this was to do something like make a copy of my original file, save the old one, and then make changes so that if it messed up, I could go back to the original one and not lose the original. And that ends up getting very, very messy, especially as you get into larger projects and working with multiple people. You'll end up with a lot of different old versions, and it might be hard to keep track of. So Git makes it very easy to save an original version of your code, test out new changes that you might want to add, and only when you're sure that you like these changes, that they work, that you want to what's called merge them back in with your original file, can you merge them back with the original file that you were working on in the first place. And the fourth and very valuable thing that Git can be useful for is for reverting back changes to older versions of your code. Say you made a change to your code somewhere along the way and realized later on that that's not the change that you actually wanted to make and that you would want to go back to an older version. Git makes it very easy. As long as you know which version you want to go back to, you can just go back to that old version and kind of start over from wherever you were previously. So that's sort of an overview of kind of what Git is and the things that Git can do for you if you leverage its functionality well. And now we'll begin to go into the actual commands that you would need to use and need to type in order to make all of this kind of work. Questions before we go on? OK, fantastic. So first command that will be really valuable to know is what's called git clone. Git clone is a command you would type at the command line, and I'll show you how this works in a moment. And essentially what git clone does is you type git clone followed by some git URL, where that URL is the address of some GitHub repository. And remember, a repository is just a collection of files and folders that are being tracked by Git. And it'll make a copy of that repository that lives somewhere on the internet, potentially on GitHub, but there are also other services that do similar things. And it will make a copy of that repository on your computer. So you can begin to make changes on your own computer. And side note, you can also do something called creating a fork of a repository, where if someone else owns a repository online somewhere, you can fork it, which just means you create kind of your own copy of that repository that also lives online. But we'll get to that potentially later. So if this is GitHub, imagine this being some kind of server, and this is a file that's being tracked via Git in some Git repository. If I were to type git clone followed by the URL of that repository, then this file, I would clone it, and it would make a copy of the entire repository that is now saved on my own computer. Make sense? OK, fantastic. Next thing that's important to know is a command called git add. So git add is what you would do after you've cloned a repository. And so now you have a copy of that repository on your computer. And say you're making changes to that repository, changing the files, changing the code. And now you want to say that the next time that Git saves a change to this repository, you want Git to save the change that you made to that file. So let's show you what I mean by this. Let's say that we've just cloned this file. So this file now exists on your computer. It's being tracked by a Git repository. If I make a change to the code, maybe add a line to that code, and I want to say that Git, the next time you save a change to this repository, I want you to track that change, you would say git add followed by the name of the file, whatever that file happens to be named. And then it would say changes to be committed, and it would track that this is a change that you now want to make to that code. So let me show you what that looks like really quickly. I have here a GitHub repository. So they usually live at some link like github.com/some username. My username is BrianU28 / whatever the name of the GitHub repository is. In this case, this repository is just called Seminar. Up in the upper right-hand corner, you'll see a button that says clone or download. And if you click on that link, it will give you a link that you can copy in order to clone this repository to my own computer. And so I could copy this, and then I could go into CS50 IDE. And then if I were to type git clone followed by that URL, it would clone the repository and save it to my computer. In this case, I've already done it, so I'm not going to do it again. But you'll see here I have this folder called Seminar. And that folder is just my copy of the repository that exists on GitHub. So we'll take a look at the file that's in here. There's two files in here, but swap.c is the one that I'm interested in. You might recognize this file from a previous lecture. It was just the file where we kind of set two variables equal to two different numbers in C, and we want to swap them. But what you'll notice here is that this code is incomplete. It says swapping right now, but we don't actually swap the values just yet. So what I'd like to do now is I'd like to add these I'm going to change this code so that it actually swaps the two numbers. And then I want to git add those changes so that Git knows that this is a new version of the file that I want to save. So I'll just quickly add the necessary code. And those 3 lines are going to swap the file. And so now, if I cd into the seminar directory, what I can do is I can add the changes that I just made. And Git will then track those changes so I can save them in the future. And in fact, one kind of little tip that might be helpful is that if I ever type git diff at the command line, it will show me all of the changes that I've made that I haven't tracked yet. So I type git diff, and it shows me down here that these are the 3 lines highlighted in green that I've added. I added this in temp equals x, x equals y, and y equals temp. And those are now changes that the next time I add a file, they're going to be tracked by Git. So I can do something like git add swap.c, and that will add the swap.c file as a file that I now want to track the next time I save a change. So git add swap.c. And so that now has been added to the changes that I want to track. So what's the next step? The next step is called git commit. Once I've added all the files that I now want to save, now I need to actually make the save. So git commit, you might think of as the equivalent of telling Git to save a version of this repository. So the syntax looks something like this. You would type git commit followed by -m, and then in quotation marks some message. And that message is just going to be usually some summary of the changes that you've made in this particular change, so that if anyone were to kind of go back and look at what we call the commit history, they would be able to see all of the changes and when you made those changes and what changes you made at any given stage in this program. So that's what git commit is, and it saves those new revisions of a repository and kind of records a message along with it. And just as a side note, if you'd like to combine the adding and committing steps together into one step, this command right here, git commit -am, A for all, or A for add, will automatically add all the files that you've changed and also commit it with a commit message. So you can combine both of these steps together. So I'll show you what this looks like. When I type git commit and follow it by kind of a message suggesting what it is that I've changed, then what Git will do is it will take my file and it will save kind of a new version of it. It'll save this version, which says that I've added a line. It saves the message along with the commit. But it also still remembers that old version, such that if I ever wanted to go back to that old version, I could still do that. So I'll show you what that looks like right now. So I'm back here, and I've made these changes. I've already added them. So I can do git commit -m, and then in quotation marks, actually swap the values. And that's going to be my message saying, here's the change that I made when I just made these changes to the code. And so I see this, what's called a commit hash, which is just an identifier about the commit. And it says I've changed one file and added 3 lines, which is indeed true. I added 3 lines to this file in swap.c, and those are the changes that I have just now saved. So what can I do now? Git status is a helpful command, where at any stage in working on a Git repository, if you ever want to see kind of what's currently going on in the Git repository, you can use git status to gain some kind of insight into what's currently happening, what are the changes that I've made to my current repository. And so the way that works is that if I were to type git status into the command line, I would see a message show up that says, what is the current status of my repository? And the message might look something like, on branch master. And Git has a feature which we'll get to in a moment called branching, which basically lets you keep track of different versions of your code. So you can have kind of different separate tracks of your code. So if you want to test changes or try and implement new features, you can do that separately from kind of the main part of your code, where master we consider to be kind of the default code. And the second line here says, your branch is ahead of origin master by 1 commit, which is just kind of a fancy way of saying that that version up here on the server, this version that we have is 1 commit or 1 version ahead of that version. So we've saved one change that the server up on GitHub doesn't yet know about. Clear so far? OK. And I'll show you exactly what that looks like. I can type git status right now, and it will tell me that exact same thing. I'm currently on branch master, and CS50 IDE is really nice in that it actually tells me right here in my prompt what branch I'm currently on. I'm on the master branch. And it says that I'm ahead of origin master, which is the version that lives up on GitHub, by 1 commit. So 1 revision ahead. So now that I'm 1 revision ahead, how do I then take those changes and what we call push them back up to GitHub so that the online version that can be accessible by anyone looking online or accessible by collaborators who are also using the same online repository can then see? And that is git push is the command that we would use. And so the syntax for that is just git push, which will send whatever committed changes we've made up to the remote repository up on GitHub. I can be very explicit and state exactly what branch I want to push to, as in git push origin master, meaning push these changes to the master branch. But generally, you wouldn't need to do this for normal purposes. So I would say something like git push. And then this new change, the change that I made on my computer, would then get pushed up to GitHub so that anyone looking online would then be able to see those changes that I just made. And so I'll show you what that looks like right now. If I go back here, so again, I did git status. I'm ahead by 1 commit. Because right now, I've added these 3 lines that actually perform the swap. And on GitHub, if I were to look at swap.c, this is online on GitHub, swap.c doesn't have those lines right now. On the online GitHub version, it just says swapping. But if I go back into CS50 IDE and I type in git push, those will push those changes back up to GitHub. And if I go back to GitHub and refresh the page now, I'll see that indeed, these 3 lines that I just added have now been pushed up and online. And if you actually go to github.com/brianu28 / this whole link, you'll be able to see this exact same thing because this repository is public. So those changes have now been pushed online. Questions on how that worked? Fantastic. OK. So now, git pull is another valuable command. Git pull is kind of the opposite of git push. If git push means I made changes on my computer and I want to send them up to GitHub so that the online version knows about it, git pull is GitHub contains a more recent version of the repository than I have on my computer, and I'd like to take those changes from online and pull them down onto my computer so that I can see the most recent version of the repository that's currently reflected on GitHub. And so the way that would work is if someone were to make like a 3rd change to this repository, and my computer only had these 2 revisions to the repository, I could say something like git pull, and this 3rd change to the repository that was added would then be pulled down onto my computer so that my computer now has all the versions that are matched on GitHub. So I've actually set up a second IDE workspace. So this version has all the changes we just made. In this version of my workspace over here, which is a completely different workspace, inside swap.c, I haven't updated it to the latest changes yet because I haven't done a git pull. So it still says swapping, and it doesn't have the latest version of the code. So if I want to pull from GitHub, get the latest version, I would cd into the seminar directory, and then I could say git pull. And so it will pull the latest changes from GitHub, and you'll see that it says fast forwarding this swap.c file. It changed one file, added 3 lines. And indeed, if I go to swap.c now, that file that I just changed, you'll see that those 3 lines that were on GitHub but weren't on my computer before are now on my computer because I did git pull. And so those changes are now reflected there. Clear on that? Fantastic. All right, let's talk about merge conflicts. This is where it gets to, this is the part of Git that can often scare a lot of people. But don't worry, it's actually quite manageable. So here comes the question of Git seems to be very good at automatically tracking what changes I've made to a file, where I've added new files, where I've removed lines, where I've added new lines to code. But what happens if I'm working on code on a particular line, and I make a change to line 28, say, and some collaborator also makes a change to that same line, and we both try and push that code up to GitHub? Git's not going to be able to know what to do about that situation because it doesn't know kind of which version of the code to believe, so to speak. So this creates what we call a merge conflict. When in trying to combine 2 different versions of the repository, there's some sort of problem that Git can't automatically resolve. And so you, the programmer, need to figure out how to resolve that conflict. And so here's what that might look like. Maybe if you try and git pull, and you're pulling in new changes from GitHub, but those changes conflict with changes that you've made on your computer, you might get a message that looks like this. Conflict, the merge conflict failed. You need to fix the conflicts and then commit the result. And so this might be what your file would look like after you get this merge conflict. You might get a situation where you have a whole bunch of lines of code, and then this weird kind of series of less than signs followed by head, a bunch of equal signs, and then a bunch of greater than signs followed by some weird sequence of numbers and letters. This is kind of what a merge conflict might actually look like. And just to break this down for you, here's what all this means. Everything between head and this set of equal signs are all of the changes that you made that are in conflict. So changes that you've made on your computer. Everything between all these equal signs and this series of greater than signs are all of the changes from GitHub that you're trying to pull down that are in conflict. So what happened here seems to be that the online version seems to have said int b equals 0, but my version on my computer, I've committed that int b should be equal to 2. And those were the same line. So when Git tried to merge those 2 together, it didn't know which line to go with. And so that's why we're getting this conflict. And this random sequence of numbers and letters right there is the conflicting commit. Every single commit gets a unique identifier, just a sequence of numbers and letters. And so this is telling me which is the commit from GitHub that is causing this conflict, that is the reason why I'm not able to merge these 2 together. And so what do you do in a situation like this? To resolve this merge conflict, all you need to do is get rid of this headline, the equal line, the greater than line, and then figure out what to do about these conflicting lines. You might delete one set and only use the other. You might somehow find a way to combine the 2. But in some way, you need to tell Git what the actual version of the code should look like. So in this case, we might get rid of all the lines except for b equals 2, because b equals 2 is the version that I know that I want. You can get rid of the extra space there. And after that, I could commit this file. And now that would be the version that's saved. I've now resolved the merge conflict by specifically telling Git which version of the code that I want to use. So let's try and create a merge conflict right now so we can see what that looks like. In one version of my IDE, I'm going to take this x, which is right now 28, and I'm going to set it to pick a number, any number. 51. And I'm going to git commit am. And I'll say, so what I'm doing here is I'm adding this change that I just made and committing it, saying I'm going to change x to 51. So I've made that commit. It notes that I've only changed one file. It says one insertion, one deletion. What that means is I deleted the line that says int x equals 50, or int x equals 28, and I added the line that says int x equals 51. It doesn't know that I changed like 2 characters. It knows that I got rid of a line and replaced it with a line. I can git push now. And so that change, changing x to 51, is now online. So if I go to GitHub and I refresh this, right now x is 28. Now I see that x is 51, because that's the change that I just pushed. Now in this other version of the repository, where x is still 28, why don't you pick a different number? 17. 17. And I'm going to say git commit am, change x to 17. So I'm saving that change. And let's say now I wanted to pull the changes from GitHub, make sure I have the latest version of the code. I've changed x to 17 here. The version on GitHub has a recent change that says we've changed x to be 51. So when I git pull, watch what's going to happen. I'll close this file for now, but I press git pull. And it says conflict, merge conflict in swap.c. The automatic merge failed, so Git couldn't merge these two files automatically. I need to fix the conflicts and then commit the results. So let's open up swap.c and see what's going on. And you'll see kind of, oh, and CS50ID actually adds some nice little markers that help us understand what's going on. But we see this head, and we see this commit hash, and we see what the different versions are. This is my version that says int x equals 17. And this is their version that says int x equals 51. That's the version that we just pulled down from GitHub. So I need to decide kind of which version of the code that I actually want to use. Maybe I don't know, and maybe I just want to go with, I don't know, the average of the two. We'll do like, what is it, 34? And then I would get rid of kind of these lines that are conflicting. Ooh. I'm not too used to the syntax, but oh, here we go. So I would just say int x equals 34, and I'll get rid of all those extra lines. And so I've now changed this code, gotten rid of all those excess lines, and just replaced it with kind of the line that I actually want, in this case, the one that says int x equals 34. At this point, I can do git status just to see what's going on. It says that I have unmerged paths. I need to fix the conflicts and run git commit. I will do git commit am, and I'll say, I'm going to commit these changes. I just fixed the merge conflicts. So now it says I fixed it. I can now git push, which takes these changes. I just fixed the merge conflicts. I'm going to push them back up to GitHub. I git push. And now after that's done, I can go back to GitHub, refresh the page, and x is now 34. And this is my resolution to this merge conflict. Kind of a lot of stuff happening simultaneously, but does that make sense? Any questions on how that merge conflict happened, why it happened, or what we were able to do in order to fix it? All good? Fantastic. OK. Let's move on then. Git log is another very useful feature. And git log's job is basically, it will tell you kind of the history of all of the commits that you have made previously. So it shows a history of the commits and their messages. So if I do something like git log and type that into my terminal, then something like this will show up, where it will show me a history of all of the commits that I've made. It will show me the kind of commit ID, or the commit hash that identifies that commit. It'll tell me who made that commit. So if multiple people are collaborating together, it'll tell you who made the change, when they made the change on a particular date. And then this message here is whatever you said was the commit message. So that's why a commit message can be very, very important, because when you use git log, you'll see all of the changes that were made. And the message is a very good indicator as to what was changed in this particular version. So make sure you use good commit messages if you're going to use Git. Questions on git log? I'll show you what that looks like in the actual terminal. I can type in git log at the terminal, and it will show me all these changes that I've made. So I added the swap file, changed x to 17, fixed these merge conflicts. Those are all the changes, and you can see kind of when I made those changes and who made those changes. Clear? Fantastic. All right. So now let's say I made a change, but I didn't mean to make that change, and I want to kind of go back to a previous version of the code. That's what git reset is for. That allows me to kind of roll back. These changes didn't work. I want to go back to an older version. And here's how that works. So recall that every one of our commits has a commit hash, some unique identifier that says this is how we identify this particular change. And down here next to the commit messages, I've included the first couple characters of those commit hashes. If I type git reset --hard followed by some commit hash, and usually you don't need to include the entire commit hash, because usually it's dozens upon dozens of characters. Usually just a couple characters, at least enough to uniquely identify that commit so that no other commit has those same initial characters, is sufficient. If you type that, it will revert your code back to that previous version, and you will lose all of the changes that you've made since that version. So do this only if you were sure that you want to go back to that previous version. In addition to going back to a previous version in your commit history, you can also go back to the version that currently exists on GitHub. So if there were a version on GitHub, which is our origin in this case, the origin of the repository, and we've made changes on our computer, and now we realize those changes really don't work, I really want to go back, you can use git reset -- hard origin/master to go back to the version that's on GitHub and its master branch. And again, we've only been working on the master branch so far, so that's the only thing that we really have to work with. So I could type git reset -- hard followed by 4761626, where that is the beginning of the commit hash for this version of the repository. And again, if I don't know what the identifier is, I can always use git log, the command that shows me the history of all the commits that I've made, along with when I made any particular commit and what changes were made in that commit. So that can give me the identifier. And if I do git reset, then these changes that I've made after that file will kind of go away, and I'll be left with this being the most recent version. And so that's what I'm going to have left over. Any questions on that? OK. Let's get into talking about branching. So branching is a very, very valuable feature in Git that basically allows you in a single repository to have a couple different kind of versions of the code that are going on simultaneously. So maybe you have one version of your code, your master branch, that's generally the one that works perfectly or that does what you need it to do. And maybe you want to add new features to your program, or you want to add something brand new to your code. But you don't want to potentially mess up the master branch because that one you know works. So one thing you can do is you can kind of branch off, create a new branch that you're making new changes to, testing out new features, while keeping your original master branch identical. And then you can make commits to this new branch. You can roll back those commits and do all the same things that we were just talking about previously in the seminar. And then only when you feel ready that this new branch has all the things that you want it to have and is ready to kind of become the official version, can you then merge it back into the master branch so that you then have the one working version. So let's explore how you do that branching. So just to recap, branching is a version of the repository. Each branch has its own commit history, and each branch has its own kind of most recent version of the code. So git branch is the command that you would use in order to create a new branch. So if I just type git branch, it will show me all of the current branches that I have on the repository. But if I want to create a new branch, I would type git branch followed by the name of the branch. And I could just make up any branch name I want, so long as it's not a name that already exists as a branch. And then once I've created a new branch, if I want to switch to that new branch, I would use git checkout. So git checkout followed by the name of the branch will switch me to that new branch that I'm going to be working on, that other branch. And side note, if you want to kind of combine these two steps to check out a new branch and create it at the same time, you can use git checkout -b and then followed by a new branch name, and that will both create a new branch and it will switch you to it. That can just be a little time-saving feature. So right now, I just have one version of the code. It's the master branch, the original version by default. And if I were to type git branch tests, that would create for me a new branch called tests that basically will just be a copy of master, at least for the time being, creating that new version of the code. So then I can make new changes to this test. I can add files to it. I can make commits, so saving reversions of this tests branch. And then later, once tests is the way I want it to be, I can merge it back in with master. And so we'll look at that right now. Git merge is the command that we would use to merge two different branches together. And the way that works is like this. Git merge followed by some branch name merges that branch with whatever branch I am currently on. So what that means is that if I am currently on the master branch, and the tests branch now has kind of a whole bunch of versions to the code that have been made. So it's got a whole bunch of files that have been changed. And I now want to take those changes and say, I want to bring them into the master branch. Then the command that I would use here would be something like git merge tests. And that would take all these changes to the test branch, and it would merge them with the master branch, so that the master branch now reflects all of those changes. Now, there may be the possibility that on the master branch, I've made changes to the same lines of code that the test branch also made the changes to. And in that case, when you try and merge tests into the master branch, you're going to run into another merge conflict. And we've talked about how to resolve those. But basically, it involves getting rid of those lines you don't want, and then figuring out how to take the two kind of different versions of the code and figure out which version you actually want. So that's oftentimes a possibility that you'll run into, especially on larger projects where multiple people are working on the code simultaneously and potentially working on different branches. It may very well be the case that merging two branches can result in a merge conflict. So let's take a look at how this might work. So as you can see right now, I'm on the master branch of this repository. And I can see this even more clearly if your terminal doesn't display what branch you're on, just by typing git branch. And that will tell me that there is only one branch in this repository, and it is called master. So let's say I want to create a new branch. We'll call it, let's say I wanted to separate out this code, the code that does the swapping, into its own function. But that seems like it has the potential to go wrong. It might not necessarily work. So I don't want to just change this file. I want to create a new branch that will let me test out those changes without worrying about whatever's happening in master. So I'm going to create a new branch via git branch, and I'll call it function, just because the purpose of this branch is I'm going to be creating a new function in order to perform the swap. So I type git branch function. And now if I were to type git branch, you'll see that I have two branches going here. I've got a master branch, and it's green, so that says that's the branch I'm on right now. But there's also a function branch that appears now. That's the branch that I've just created. And if I want to switch to that branch, I would type something like git checkout function. And it says switched to branch function. And so if I type git branch, I would see there are two branches still, function and master. But function is now the green one with the star next to it. That's the branch that I'm currently on. So now I'm on this function branch, and I can add this swap function, void swap int star a, int star b, and int temp equals star a equals star b, and star b equals temp. And I can now replace this with just swap address of x, address of y. That should work, right? Hopefully it works. I'm going to commit those changes. I'm going to say add a swap function. And so that change was just made. And so it says one file changed. I added 8 lines, removed 3 lines. And so that commit is there. But now, if I type git branch, I can see I'm currently on the function branch. If I were to check out the master branch via git checkout master, what you'll notice is that swap.c changes. It changed back to the version that's on the master branch. Because the master branch doesn't have the new function. It just has these 3 lines of code that are right inside the main function. Watch again. If I git checkout back to the function branch, watch what happens to swap.c. It'll just immediately show me, here's the version that's on the function branch. And so those are those changes. Question?
Will this work on any file system, say the Mac Finder?
Yeah, so on the Mac Finder, if you do a git checkout and maybe this new branch has a file that didn't exist on the other branch, that file will appear in your file system. Yeah, so it absolutely works. And so now maybe I'm happy with those changes, and I want to, let's actually make sure it works. Make swap /swap 3450 5034. Fantastic. That did in fact work. So now I feel comfortable merging those changes back into the master branch. So I'm going to go to the master branch via git checkout master. And notice once again, this is the version that's currently in the master branch. And my function branch has that new commit that I want to merge in. If I type git merge function, what that's going to do is it's going to take the changes on the function branch, and it will merge them into the master branch so that that new commit, that version where I made the new function, will now become part of master. And there shouldn't be any merge conflicts because I haven't changed master. So I press return. It makes those changes. And now this is my master branch. And I have that swap function. And you can show if I type git branch, I am still on the master branch. But that new function that I created in the function branch now exists in master. And at this point, if I wanted to, I could delete the function branch because I no longer need it. And the command to do that is git branch -D for delete, followed by the name of the branch. So git branch -D function, deleted branch function. So now if I type git branch again, I only have the master branch. And if I were to git log to look at all the commits that I've made, I would see that add a swap function is now there as a commit in the master branch because I merged those commits into that particular branch. Any question on how that works? And so merging and having branches is a very, very powerful tool, and I would highly recommend it when you're working on your final projects, because if you want to kind of be a little bit ambitious and potentially test new changes to the code, this can be a good way of making sure that you still hold on to the original while still allowing yourself the creative freedom to experiment and make changes and mess with the stuff that you've already written. All right, and last thing I'll kind of briefly touch on but won't do a demonstration of is something called pull requests. This happens very frequently in open source projects especially. But if you've made a change to a repository either in a separate branch or potentially in a fork, like I mentioned earlier, where a fork is just kind of your version of someone else's repository, sometimes you may want to request to kind of merge those changes back into the original version. And so this would be when you would submit a pull request, as the terminology goes. And so if you hear that, know that all that means is that you've made changes to some repository, either in a different branch or in a different forked repository altogether. And you would like to then kind of merge it back into whatever the original version was. And this is typically done via a pull request. And GitHub has functionality built into it to allow for pull requests to happen and to allow for whoever owns the repository to kind of review pull requests, look at the changes that people have made, and either decide to approve or reject those changes. So once again, Git is a very valuable tool that helps you kind of keep track of different changes to your code, makes sure different collaborators can work together on the same repository, makes sure you can be ambitious and test new changes without losing the original copy of your code, and also allows you to, if you ever do make a mistake, to go back to a previous version. So as long as you are kind of frequently making commits, saving the work that you're doing, this can be a very, very valuable tool for keeping track of the different versions of your code and making sure that your project is under control. I'll take any questions now, but that's what I had for you today.
Thank you.
All good? All right, fantastic. Thank you both for coming. Yeah.
Question. Can you walk through quickly what happens when we do a submit 50 on our presets?
Oh, yeah. So submit 50 is, OK, let me make sure I'm remembering this correctly. Submit 50 is basically what that's happening is every time you submit 50 something, you are submitting kind of a new branch to your submit 50 repository. So when you typed in something like submit 50 pset 7, what was happening is behind the scenes we were creating a new branch called pset 7, and we were kind of pushing all of those changes to GitHub as a brand new branch. So if you were to ever go to github.com/submit50/your username, that in itself is a repository. Each student in the class has a repository. And within that repository, there are branches for each of the different times you submit 50. So there's a submit 50 for Mario, there's a submit 50 for 15, there's a submit 50 for the test, and each one of those are just different branches that are named with whatever the name of the problem is and the name of the problem set or the name of the test. And so whenever you do a submit 50, it pushes those to a new branch. And then what we do is we tag those changes as a new release such that it makes it easy for us to kind of look at all of the changes that you've made. We didn't go into tagging and releases in this seminar, but it's just yet another way of kind of keeping track of different versions of code and keeping track of different changes to it.
And is a release just say a big moment in the code's history where it said this is working, this is now release?
Yeah, that's typically what it would be used for, exactly. And so when you submit something, that's kind of our semantic equivalent of saying that you've now supposedly gotten your problem set working, and this is the version that you want graded, and so we'll tag those. And that's kind of the way it works. Yeah, good question, though. OK, thank you so much.